Event listeners are crucial for creating interactive web applications. They allow you to handle real-time user interactions, dynamically manipulate the document object model, also known as DOM, and enable asynchronous event-driven programming. Let's look at a basic example. Here we have a piece of code that shows how an event listener is attached to a button element. First, the button is selected using document.querySelector method, and then addEventListener method is called on the button element. This method takes two arguments. First is the type of event, which in our case is click, and the second one is the event handler function, which will be called when the event happens. Inside the function, we are simply logging the message button clicked in the console. There are multiple ways to attach event listeners to elements. The modern and recommended method is using the addEventListener function, which allows multiple listeners of the same event on a single element and provides detailed information about the event. In this example, we are selecting a button using querySelector and then adding a click event listener to it. The event listener calls the handleClick function. The event object here can give us the information about the target of the event. This is the preferred method. The older approach uses the onClick property of the element. It is not recommended since it allows only one listener per event type, and also doesn't allow to remove specific listeners. Here the event handler function is directly attached to the onClick property of the button. This will override any previous event handlers attached to the onClick property. Whenever an event occurs, an event object is created and passed to the event listener. This object contains information about the event and provides methods to manipulate it. Some common properties of the event object are type, which gives the type of the event, timestamp, which gives the time when the event occurred, target, which gives the original element on which the event happened, current target, which gives the element on which the listener is attached, client X and client Y, which gives the position of the mouse pointer during mouse event, and event phase, which specifies the phase of the event. The event object also has some important methods. PreventDefault method is used to stop the default behavior of an event like a form submit. StopPropagation method is used to stop the event from bubbling up the DOM tree. The example shows how to prevent a form submission using PreventDefault and how to stop the event bubbling using StopPropagation method. The addEventListener method also accepts an optional third argument, which is an options object that can be used to control the behavior of the event listener. The passive option, when set to true, tells the browser that the listener will never call PreventDefault method, and this allows the browser to perform optimizations which can result in better scrolling performance. This is recommended for touch and wheel events. The once option, when set to true, makes the event listener automatically remove itself after it is executed for the first time. This is very helpful for one-time events like initialization and cleanups. In the code blocks, we have shown how to use passive and once options using the options object, and passing that as a third argument to addEventListener method. Event delegation is a pattern where a single event listener handles events on multiple elements. It uses the event bubbling concept to catch events at the parent element. This is more efficient than attaching listeners to each child element, and also works with dynamically added elements. The code block on the left shows the non-optimized way of attaching event listeners to multiple buttons. Each button gets an event listener attached to it. On the right side, the optimized way is shown where the event listener is attached to the container element and we check if the target of the event is the button element. Event delegation improves the memory usage, automatically handles dynamic elements, and leads to a cleaner code. Debouncing is a common pattern which limits the rate at which a function is called. This is especially useful for search inputs and window resize events, where a function should not be called on each character entered in the input or each pixel the window is resized. In the provided code, we have a function called debounce, which takes a function and a delay time as input and returns a new function. The returned function uses setTimeout and clearTimeout to delay the execution of the original function based on the delay provided. This is how we limit the rate of execution of the function. There are various ways of event binding. First is to use a named function reference, The second is to use an inline function with component context, and the third is to use a single handler function for multiple events. We should choose a pattern depending upon the situation and our requirements. It is very important to properly manage event listeners because failing to do so can cause memory leaks and affect performance of the application, especially in single-page applications. Always remember to remove the event listeners when the elements are removed from the DOM. Here we have a code snippet which shows a cleanup method, which removes event listener of the button when the component is removed. Some best practices to follow are to always clean up listeners when the elements are removed from the DOM, use event delegation for dynamic content, enable passive listeners for scroll and touch events, bind the event handlers in the constructor to maintain the correct this context, and implement cleanup methods in components. On the right-hand side, a cleanup function is shown which removes all the listeners and empties the array. Let's summarize the main points we discussed. Always use event delegation for dynamic content and to improve performance. Implement passive listeners for better performance, especially during scroll and touch events. Always clean up the listeners to avoid memory leaks. Choose the right event options based on your use case. As an advanced tip, consider using an event handler manager, which is like a class that can manage all the event listeners associated with an element. This simplifies attaching, managing, and cleaning up the listeners. In the code provided, a class named Event Manager is created which has the on and cleanup methods. The on method attaches an event listener to the given element, and the cleanup removes all the event listeners. It is also recommended to use weakmap for automatic garbage collection of removed elements and their associated listeners. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.